So what we have here is a mass of 12 kilograms rests on a rough horizontal table and is attached by two horizontal inelastic strings to masses 10 kilograms and 4 kilograms which hang over smooth pulleys at opposite edges of the table. The coefficient between the 12 kilogram mass and table is mu. Show that if mu equals a quarter, the common acceleration of the particles will be g over 26. 3g over 26. What is the least value of mu for which the particle will not move? Alright, so we're going to draw a diagram starting off. So I'm going to set up my table. Then once I set up my table, I'm going to set up a smaller box, like so. This, and then on the far side, it's just going to be these like small pulleys that the two other weights are going to be hung from. So there's one there and there's one there. Okay, so we're going to have two strings. It's going to go over and down, and then this one is also going to go over and down. Then we're going to have two new blocks after that. We'll call them this one here, like so, and this one here. Okay, so 12 kilograms. Reaction force R, weight of 12g, R equals 12g. The friction force, whichever way it goes, so I have a choice where to put the 10 kilogram mass. I'm going to put the 10 kgs here and the 4 kg here. Means nothing else other than that the acceleration is now going to the left. So they all have a common acceleration A. Okay. Next thing after that is what am I going to call the tension? I'll call this one tension the T. This one over here can be tension S. And up. Okay. Now, tension is all about the perspective. Are you being pulled to the left or pulled to the right by the tension? Are you being pulled upwards or are you being held upwards by the tension? It's all about perspective, okay? So we're going to start off. Which way do you think the friction's going, guys? The friction? To the right. So friction equals FIR equals a quarter R. And R is 12g, so it's quarter 12g, 3g to the right. Friction, okay, is 3g to the right. Now, let's get some equations going. Let's start off with easy ones, okay? Force equals ma, so force equals ma. Okay, or ma equals force, whichever way you want to look at it. Now, ma equals force. On the 10 kilogram particle, it's going downwards. So it's 10a going downwards. What else can you tell me about what other forces are going downwards for the 10 kilogram mass? What's going downwards on the 10 kilogram mass? Sorry? 10g acceleration due to gravity. 10g going downwards. What's going upwards? Minus t going upwards. There's your 10 kilogram mass done. What about your 4 kilogram mass? Any takers? 4a in which direction? Up equals s going up minus 4g going downwards. Okay. 12 kilogram mass. We'll do it a bit lower again. 12 kilogram mass, anybody? So start off with ma. What's ma? 12a. Going which direction? Left. What's pulling it left? T. What's pulling it right? Minus s going to the right and minus your 3g friction. Okay. Now all this gibberish, you can just wind this all down to 3 pieces of information or 3 equations. Just keep get rid of the directions after that, and then you're done. So you have your 3 equations here. We'll just stack them. There you go. Now, what is the question specifically asking us for? Common acceleration. It'd be great to know what A is. Okay, so I'm taking there's a really cheap way here, isn't there? Once if we add all three equations together. Do you see what's happening here? 10a plus 4a, 14a plus 12a, 26a. Now look what happens here. 10g minus 4g, 6g minus your 3g, 3g. And look, t plus t, or minus t plus t, cancels. S minus s, cancels. So by adding them all three of them together, just worked out really conveniently. You then just add all three together, no bother. A equals 3g over 26, exactly what I was asked to prove. Is that right? Yes. In the event that you weren't able to spot that, okay, what you could do is this. You pick a letter to get rid of at a time. So I rearranged the first equation to get t on its own. So t equals 10g minus 10a. I look for another equation that has t in it. You can see this is so equation A is where I got this from. And now I'm going to put equation A into equation C. So I'm going to do the green to tell you which one I'm using. 10a equals 10g minus 10a, because we replaced what t was, minus s minus 3g. Then I'm going to go across to equation B, and I'm going to get s on its own. To get s on its own, it's going to be s equals 4a plus 4g. And now I'm going to get rid of this s using 4a plus 4g, so I'm going to get 12a equals, so I use a neutral colour now. 12a equals 10g minus 10a minus s, which is going to be minus 4a minus 4g minus 3g. Have a look here now. You're going to get minus 10a. That's going to be minus 14a, isn't it? Bring it over to the other side. 26a, 10g minus 4g minus 3g. Get you 3g. A equals 3g over 26. So you can do it substituting in the two letters you want to get rid of. Okay. What was the other question we were asked then? For which the particle will not move. Okay, if it's not moving, so the minimum value of mu. So I had to change the 3g into what? Sorry? The 3g has to change into, I think it has to change into mu g, doesn't it? Because it wants the minimum value of mu. So it has to be mu g. Now, we're going to get here? Yes. So lads, when you remember earlier that we had mu g was a quarter of r. But if we don't know what it is, it's going to be mu times 12g, which is 12 mu g, which is what William was saying there. So 12 mu g instead this time around. Now, what happens here, guys, is we're going to add directly downwards like last time. 10a plus 4a plus 12a, 26a. Add downwards. S minus the other s cancels. T minus the other t cancels. We're going to get 10g minus 12 mu g. Now what we've been told is that the acceleration equals 0. So if it doesn't move, this whole system has to equal 0. No net force. So then we're going to get 10g equals 12 mu g. Cancel the g's. Mu will equal 10 over 12, which is 5 over 6. Anybody get that? 5 over 6? Sorry lads, so when I add it downwards, see the 10g minus the 4g? That's 6g, not 10g. So that is 6g minus 12 mu g, and then mu g is then going to be 6 over 12 as opposed to 10 over 12. That's where I went wrong. System was perfect, just me adding, not taking 4 away from 10 properly. So divide by 12 and you get mu equals a half, which is what you guys were saying earlier. Sorry about that. Now,